Good morning, everybody, and welcome to the Drake Forum at Hamvention 2015. In terms of the volume, can everybody out there hear me? Is there anybody that doesn't want to hear me? Oh, okay. Security, you want to take this hose and take him out to an attitude adjustment out in the alley there?
I'll get it.
This theme for the Hamvention 2015 is home brew, and I think each and every one of us does do home brewing, whether it's just fabricating cables, making an amplifier, an antenna tuner, something we're all doing home brew. But it's the military that protect our right to use that communication equipment to talk to people worldwide. Let's show an appreciation for our active duty and retired military. And let's just take a moment to pause for those silent keys in military that are no longer here. I'd like to thank everybody that's participated with the preparation of this forum. We've got Aaron, N8QID, Mark, N8PEP that are doing the video. Mark, WB0IQK, he's our IT person that does all the slides and so forth. He does all the behind-the-scenes action. And certainly thank all the people at Hamvention when you see the volunteers in the flea market. Okay, we're going to be talking about several topics listed here on the agenda today. We've got interesting presentations, and I'm going to be zipping through mine because we'd like to give Jeff and Ron as much time as possible. These are the Drake nets that are out there. We just have a West Coast net that started recently. I've been trying to check into it, but with propagation on 80 meters, it's been really difficult, but we're going to keep on trying, maybe even into the winter months perhaps. With regard to the L4B, I'm going to talk about how we might tune that up, and it's not exactly what you think. Perhaps, maybe it is. Does anybody know what these items are here? What are those things? Right. You use those on an L4B? No, we're going to tune it up with some other parts there. Sharp, man. First of all, we start out with an external, if you will, cleaning of the dust and so forth off the amplifier, and I use my wife's cosmetic brush, a new one that I stole from her cosmetic case. It's real soft, it gets the dust off the front panel, and it doesn't scratch the plastic either. There you can see how much dust has accumulated, like on the back of my L4B, and that's just from 1 year of operation with maybe 2 hours use a week, and this is in a controlled air environment, so you can see how much dust accumulates. And that little brush there, that's actually a computer duster that I've adapted to a shop vac, if you will. It does real good for cleaning off the dust. In terms of cleaning off connectors and so forth, I'm an advocate of deoxit, but you want to use it very sparingly and wipe off the access and make sure it's dry before you apply power. And you can see there, these two connector pins there have been cleaned off, and you can see how much is on that Q-tip, and that's just from 1 year in a controlled environment. And you can see the other ones, how much oxidation or dirt or whatever is there. As far as the this connector, you can use deoxit also on a pipe cleaner, Q-tip or something like that to clean the inside of that as well. In terms of doing some checks before you actually power it up, you want to make some visual inspections, like have the high voltage capacitors vented. You can see there's a little pressure relief on the top of the caps. You want to check, are any of your meter bulbs burned out? How's the SWR between your transceiver and the amplifier? Has it been going up over the months, or is it not as low as you would like? And then to also check the plate voltage, which might be symptomatic of either a diode or a capacitor problem, and check the voltage and CW, sideband, no load, full load, hard audio peaks, and so forth. And then also watch the tube color in standby to see if it gets excessively red or orange. This shows again how much dust can accumulate in just the course of a year. And you can see there's the clean part, there's the dusty part of the blower. And what I do too is when I take the cabinet off, I lubricate the blower once a year. And this is the oil that I use. It was recommended by a friend of mine that is in the heating and cooling business, and he uses that for the small electric motors. This shows one. This is the extended spout there that enables easier insertion of 1 or 2 drops of oil in one bearing, and there's the other bearing too. And you You don't want to over oil it, otherwise you're going to actually start dripping down into the sub chassis there. You want to take a look at your changeover relay also. With regard to the relay, typically what I do is I take each one of these contacts on this side as well as on the bottom side, and I run a clear piece of unused paper, white paper, through there and see if you get any oxidation or dirt. If there's very much there, you might want to try the deoxid, or you may even have to burnish the connector. Here you've got the two input wafers on the L4B. Inspect those to see if you got any dust or corrosion of any sort there, and if there is, then you can use the deoxid. I don't use deoxid all the time. I tend to let the switch tell me, do I need it or not, in terms of how much corrosion or dust might have accumulated. This is the output, the band switch right there, and that typically, unless you've done some hot switching or whatever, doesn't need any cleanup, but I do it on an as-required basis. Here again, these are the pilot lights for the meters. I typically replace those whether they're good or bad, just because it's so hard for me to lift the amplifier down to the desk and then take it apart. I figured as long as it's open, 50 cents worth of bulbs, it's worth it as preventative maintenance. This is, again, the shop vac connected to that computer keyboard brush, if you will, and I use that for cleaning all the dust off the plate tuning capacitor, which is fairly critical because there's high voltage and high RF on that. And then same way on the plate loading capacitor, although that's not as critical, it's still a good idea to get the dust off of there. In some areas it doesn't really make a difference. You can see on this coil here, here's some part that's dusty and that part has been cleaned. And you can actually get the oxidation off if you want, but I wouldn't recommend that. But it doesn't really affect the performance of the coil. I just get the dust off as a matter of course. It's the electrolytic capacitors in the high voltage line that you really have to be careful with. With regard to the input coil adjustments there, if you have changed, driving rigs, if you change the length of cables between the amplifier and the rig, if you've changed the tubes or anything like that, you may have to adjust the input coils according to the instructions in the Drake manual there. And if you have changed the tubes and so forth, or it's been a long time since you've checked the grid current calibration, this is the potentiometer that you adjust there, and the procedure for doing that is in the Drake manual for the L4B. I'm going to talk about tuning up the L4B very briefly, and there's several ways of going about it. I'll present what I do, but first let me tell you what Drake does. And we'll make some assumptions here that you're tuning up primarily for the sideband mode. Your meters are accurate, the grid current, the plate voltage, and so forth. For all the amplifiers that I've tested, I would say 60 to 75% have inaccurate grid current readings and or high voltage readings. It's not actually necessary for you to calibrate the high voltage meter. You can't really do it on the L4B without changing resistors. But if you know if you check it with an external meter and you know what the voltage is, then you don't actually have to try to calibrate it. Grid current is a little more important. You want to calibrate that circuit because you don't want to exceed that 220 mils of maximum grid current. That'll take out the tubes there. So the general tune-up procedure is to tune up the exciter with a dummy load, and if you have a antenna tuner, get it adjusted for the band and the frequency, and then you tune up with your antenna and so forth. And what I always do is I log my knob settings in terms of a plate load, plate tuning, and so forth for each band or frequency that I'm using. That way I can go back to those values very quickly. Plus, if those values change from time to time, it says, hey, I got an antenna problem, something wrong with the rig, whatever it happens to be. I'm going to talk very briefly about Drake's instructions and then tell you what I do. With Drake's instructions, they actually have two-phase procedure. They've got the if you will, the SSB and AM tuning, and then they've got the SSB operation, and you're supposed to do both of those. And some of the constructions, I sometimes have difficulty going through them, but basically what they want you to do is increase the exciter output and keep the plate current less than 400 mils, and then dip the plate alternately with increasing the load and so forth. But you want to watch the 220 mils parameter of the grid current. You want to keep the grid current under 220 mils unless you happen to be running Amperex tubes, which are a little more expensive, but they can take 250 mils of plate current. I'm sorry, grid current. Okay, what I do is when I tune mine up, a slight deviation from the Drake instructions is I either use a CW pulsar or one of those pulsars that you can put into the audio line, and I use that to feed the amplifier with something like 40 to 50 watts, and then I go through procedure of alternating between the load and the tune on the amplifier. And again, I watch for 220 mils of plate current, 220 mils of grid current. I'm getting the grid and plate mixed up, but it's 220 and the grid current that's important. And then after I get it tuned up that way, what I do is go into the CW mode and tune for maximum power output as long as I don't exceed 220 mils of grid current. And the plate current's usually going to be between 575, 580, somewhere in there. Okay, next up is Jeff Cavalli, who's going to be talking with us about several aspects of the TR7, some historical information, and you want to be sharp on this one because he's going to present information that you literally cannot get on the internet or anyplace else. A question, sir? Yes, it will. We'll be posting it on the Drake reflector and so forth. It's going to be at the WB4HFN website, and then we're going to post the video and the slides on Vimeo as well as on YouTube. So if you don't want to take notes, you want to pay attention to the narrative, we'll be having it available online. Okay, here's Jeff.
Hi, I'm Jeff, WA at SAJ, and I've got about 80 slides to show, so I'm going to move fast and try to give you as much as I can, because I got some information towards the end of my original presentation, and it's going to be pretty informative. This is for the Drake TR7 being solid state. Their ALC power control was only good for AM and CW. So if you want to go sideband and try to drive an amplifier that only required 60 watts, you could turn the mic gain down, but you still have your peak power. So what I did, and basically what that control does, that control basically controls, it's right here in the middle of the radio, after the microphone gain and all that, and it's actually at a good point. This is the schematic representation where they apply a voltage here, and it's constantly going up and down by about 0 to 3 volts as you talk. There was a time constant change on the later models to give it a little quicker, more talk power, but that's irrelevant in this instance. So what I wanted to do was try to take that same control without getting too crazy and say, well, how does this thing really work? And I did a lot of investigating, and it turns out there's the ALC pot, and that's on the bottom. You can't get to it conveniently. So I said, well, let's see if we can leave this and still maintain ALC, which in this modification it does. It's a simple mod. And by the way, this little wafer here is a turn down for 10 and 15 meters. It's actually put in there with 3 resistors, so on 10 and 15 meters you don't overdrive it. Drake was pretty smart in doing that. They were trying to keep their final at a pretty decent level and also have low IMD rating. So that's what that little wafer is for. You'll see it on the schematic. It's also in the theory of operation in their service manual. That's the pot, and everything stays the same here. So this little modification, this all stays the same. And basically what we're going to do is put a jumper in here. This jumper, or this wafer, is only in there to turn off the pot on the front. Why they didn't want you to do it is beyond me, but you know, I'm sure they had their reasons at the time. You've got to remember, this is 1977 when they were designing the TR7. So when you, in order to get to that jumper, you have to drop the front panel. To do that, you got to take off this DR7 board. And I ground the radio, make sure the radio is grounded. I use an ESD strap just to be on the safe side. It's always a good idea to do that. And that board comes off. And there's the jumper. It's right on the mode switch, right on the back of the mode switch. So when this panel drops down, all you got to do is add this little jumper right here. There's a close-up view. And if you ever want to go back to stock operation, cut the jumper and you're all done. You can go back to stock. And what happens is this control now is controlling this voltage consistently along with the ALC pot back here. This is still in operation. Nothing changes. The only thing is the front panel, hate to do this to you, this little blinky light, when you if you want to adjust it correctly, put this in a dummy load, adjust your mic gain appropriately for at full power, leave the mic gain alone, and then you can adjust your power up and down anywhere you want to go. Works great. And I've been doing it with Elecraft amplifier, which only requires 20 watts drive, 25 watts drive, and I have a couple guys that I've done them for, and they're just happy as can be, not overdriving their amplifier. The end for that. Now, if you want to add a 2.8 filter, INRAD has a 2.8 filter, and this is the part number. When you put it in, you just can't drop it in. This is where it would be. This is normally where the 2.3 is, the stock transmit filter, because these filters are for receive only. This is receive and transmit. So even though you might be receiving in one of these filters, this is your transmit one all the time. So what I did, I took the 2.3, moved it over here, so you could still have narrow sideband receive, 1.8, and then CW, and transmit through here. And when you do, unfortunately, when you drop a wide filter in any kind of radio, I don't care if it's a Kenwood, Yaesu, or Drake, you have to reset the carrier set point. You'll notice that this is the upper sideband, here's the lower sideband. I don't know, can you see the green? You see the green mark here? You're actually transmitting without alignment on the opposite sideband here. There's actual RF here. It should not be there. So the procedure is real simple because your radio has a little test facility in it called a digital readout, and it's an accurate readout within 100 cycles. And this is what it looks like after it's aligned. I don't know if you can see the difference there. See where it's on the upper sideband? There's the lower sideband in where it should be. And you see how this extended out? I'm going back and forth here. There's the upper sideband correctly set. Assuming nobody has done anything to the radio and you want to drop in the filter, you can drop it in, and this is the upper sideband adjustment right here. That happens to be a diddle stick. I didn't know of any other way to show it. I said, well, you're going to be using this. Be careful not to touch it. That's a 10-volt regulator. So you take this pot, you dial up your radio to 13.693.3 and dial and adjust this pot, whoops, for 0 beat. It'll read it right direct. You can listen to it, turn up your volume, and you'll actually hear the frequency, and that should correctly adjust the upper sideband carrier set point. You want to do the lower sideband, you adjust this pot for 13.696.7, and your upper sideband carrier set point should be pretty close. And after you're all done, again in a dummy load, use either a auxiliary receiver and dial up 14 megs somewhere on the 20-meter band, or any band for that matter, and null your carrier for minimum signal. And you're all set with your alignment, and you can transmit on 2.8 filter and be correct. See, I'm moving along pretty quick. Somebody have a question? No? Okay. This is a article I wrote for in electric radio. I got permission from Ray to go ahead and put this up, and I'm going to redo the article and put it on Ron's website here down the road. This is a range solution for, instead of buying crystals for your Drake, normally you do that or get an FS4 for $500-600 on eBay. For under $200, you can go ahead and get an Elecraft signal generator and do the same thing. Works real well. You can program these frequencies. They come pre-programmed for 12 frequencies. And then that'll plug into the back of the R4 4 line, the R4C, R4A, R4B. Right here, you just take an old crystal, put a piece of RG174 in, adapt it to this, plug in your 12-volt adapter, and you set your 0 dBm output here. This is a $180 generator. And you can program any frequency you want from 1.5 megs to 1400 megs. It's an actual RF generator. So you can program this anything you want. And I have 160 meters, there's 80 meters, there's 40 meters here. So I have all the bands that I need to use, and it plugs right in the back. So on the front of the 4 line, you just go to your number 1 position, plug in your crystal, or your oscillator, and there you are. You'll have all the bands. You can change them also. This is the output. This was probably the worst one out of all of them. The transmitter with a crystal in this position, and this is the XG3 Elecraft generator. No extraneous outputs at all. They got real high Q circuits because the generator does put out a lot of square waves. And the filtering in the Drakes are extremely high Q. So all that garbage that comes out of the generator is never seen on a spectrum analyzer. The only thing that I did have a problem with was the fact that there was a little more than 0 dBm output, so I put a little pad here, a 3 or 6 dB pad, because it tends to noise up the receiver just a little bit. It's not perfect, it's not a crystal, but it does work well. So there's an alternative for shortwave listening or any other bands you want to operate if you don't want to pay $25 a crystal. Because if you had to fill that up and plug in crystals, you'd end up with about $1,200. Or get an FS4 if you can find one. The other thing that's neat about this, you can use it as a signal generator using the crystals internally already in here. And this is the AGC threshold on my R4B at, I think that's 1 microvolt at about S2. Pretty hot receiver. I didn't do anything fancy with it. That's just the way it is. You can also use this generator with 2 sweep functions. You can program these 2 sweep functions for any band you want and any time constant and check your noise blanker. This is with the noise blanker off, noise blanker on, noise blanker off, noise blanker on. Works great. Works slick. You can check your noise blanker. How about that? Now, Drake started back in how am I doing on time, Evan, okay?
You don't know.
Okay. Drake started in 1943, roughly. Bob Drake, making filters for the Army, military. After World War II, he hired a young engineer, Milt Sullivan. Just after I did the first part of this talk here, Judy Sullivan called me, his wife, and she had all his files from R.L. Drake from way back. Now, some of them were thrown out when he moved down in the Carolinas and did consulting for Drake and consulting for Alpha Delta. You guys hear of Alpha Delta? Alpha Delta is Don Tyrell's company, W8AD. And Don and Milt worked together. Don was a marketing manager for Drake all the way through the TR7 until he left and started Alpha Delta. Well, anyway, he started with Drake in 1946 at a whopping 86 cents an hour. That's his application. There's Bob Drake's signature right there. Imagine making 86 cents an hour. And what it was in his notes, he asked for 86 cents an hour, not thinking about taxes. Oh, I got to eat. I got to have rent. So he kind of messed himself up. And Bob Drake knew that, but he wanted him, and he took care of him later on. He actually went to Collins. He actually quit Drake in the middle of his tenure with Bob Drake, and they got, not in an argument, but Bob Drake was testing him. He went to Collins for a short time, and after he sold his house and bought a trailer to move out to Cedar Rapids, Bob Drake says, "You're coming back. I'm going to pay you more money." So he came back. And this was one of his first receivers right here, the Drake 1A. These are out of his private files here, and he only kept stuff that he liked. So this is one of the things he kept. There's Milt Sullivan there with the A-line, 1960s. You see the R4A and the T4X. Here he is with Ron Waysong doing some work on a display, and Bill Frost and Joe Brunzo made up the display, and they were hooking things up and what have you, because they were going to sell consoles. Remember those consoles in the 60s where you could set your gear on? Here's Milt Sullivan with a young engineer showing him a few things. And this is his pride and joy, the Drake 2BQ. He liked that very much, Judy said. That was probably his best receiver he ever made. How about that? So there's the file that came by UPS. It was about 55 pounds. There's a lot of paper in there and a lot of notes. Right about here is a 1-inch thick private notebook that has all his handwriting and everything. And you'll see here in a little bit the details. Oh, by the way, I do own equipment. Every time I'm on the net, I'm running somebody else's radio. Well, this is my station here. So I do own some equipment. Thousands of notes here. There's all kinds of stuff. I'm going to go through it quickly. And I want you to take note of this one, QRP file. You know what QRP is, right? Guess what was in his file? Yeah, honest to God, that's what was in his file. And there was more than this. There was mostly ceramic tubes. His idea, he was working on a ceramic tube amplifier around the TR7 era. Wow. So that blew my mind. When I opened it, I go, what the hell? I couldn't believe it. Here's some of his 1960s notes here for the T4X, TR4. Everything's all hand-drawn, hand-calculated. Inductance values. I'm going to go through this quickly. Here's the R4C. Mark Gill, you pay attention. You just bought an R4C. Where's Mark at? He's not here? Anyway, here's the bandpass figures for an R4C. Everything's all calculated out. High detail. Here's the main relay for the TR4C. This is what it looked like. All again, hand drawings. The RMS breakdown voltage on the 2700. tuner. Just amazing. What's that?
4 minutes.
Okay, 4 minutes. Here's the L7 circuit. L7 tank circuit, Qs, the circuit Q. These guys that are putting in higher voltage in their L4 and L7, guess what? This goes right out the window. Your Q goes right out the window. It's not the same Q because of the higher voltage. He calculated everything out. Plate transformer, the cost of the plate transformer. Here's the cost of the copper, cost of the core. The L7 transformer costs $31.55. Here's the TR7 power supply transformer. Here's your plate choke specs for the L4, L4B, L7. Here's the SWR effects with the TR7. He had all that calculated out. Cooling fan specs. Who the heck makes specs for a cooling fan? You just throw a fan on. No. He calculated the manufacturers and the CFM output and what the cost was. Now here's something that'll blow your mind. This is a new tuner, MN7500. I never heard of it. When I saw this, I couldn't believe it. It was a dual roller inductor tuner. Here's all the knob settings and the specs where all the knobs were. He started at 3 o'clock. There's a lot of notes with 3 o'clock position, which is on the right-hand side. Here's the Smith chart. He must have 100 Smith charts in there with all kinds of calculations, all hand done. He even did some gears. Look at that. You ever see gears like that? This is the turns ratio. And he was using merchandise and a couple other roller inductor companies. They even had an MN5 to match the TR5, 500 watt economy tuner. He retired from Drake, worked for him for 4 years as a consultant, and he went to work for Alpha Delta. This is his design. You buy an Alpha Delta switch, that's Milt Sullivan. Here's the blueprint. I have about 50 of these at home. Huge, as big as that screen here. And there's some of the Alpha Delta design. Alpha Delta came out with a VRC, variable response console with a notch filter and all that, and I always wondered. I said, boy, does that look like a 2BQ? Well, now I know why. Here's a VRC hand drawing of the actual schematic, high-low pass filters. The speaker, you think you just throw a speaker in? No, he's got to calculate the dBm output from 17 cycles up to 17K. That's the way Milt was. Judy said he was just a fanatic about detail. He also came up with the Transorb, the Trans Trap, and the specs for it. And unfortunately, he passed away in 2010 because I hadn't heard from Judy in about 15 years since the Drake book was written by John Loftmiller. And thank you for watching. And that is my shack, and I do have equipment. The end.
Thanks.
That's pretty fast, huh?
Our next presenter is Mark WB0IQK, and he's going to be talking about some internal frequency displays so that you know exactly where you are on that beautiful C line. Go ahead, Mark.
Hello, everybody. A little bit of history here. About maybe 7 months ago, I found some real small little frequency displays on eBay, and I'm a big eBay guy. I like eBay. Says, boy, I got this set of twins here, and I think that would really make this thing come to life if I could put those in there. And it's so, it's only like maybe 3/4 of an inch deep. In fact, it's what Ron is using on his TR7 up here now. So anyway, here's how they look. So here it is installed. First off, the full article is on Ron's webpage. It was published in Electric Radio a couple of months ago, so step-by-step instructions. So it's nice and small. It fits in front of the PTO, and when I use the blue film, the gel, I guess it's called. So when this is out, you don't see the display. When it's on, it's the LEDs are the display's blue anyway, so it really looks nice. And there's a top view of it. Cost, $12. You can't beat that. Again, if you go to Ron's webpage, there's the seller. It runs off 8 to 15 volts. So you can tie it in to multiple places in an R4C and a T4X. More than likely, you're going to have to put a half-wave rectifier circuit in the filament line and get your voltage there. High impedance, And there's the frequency rates, 0.1 to 65. So no problem in the T4X or the R4C getting the frequency. Accuracy is 10 hertz, sensitivity. Let's see here. And you can go down to the hundredths or the tenths on your display. It's real easy to program once you figure out what the two buttons are for. And again, there's the dimensions. It took about 2 hours on the first one I did, about an hour on the second one. I did it on the C line, but it would work equally well on a B or straight twins. You can have a positive or negative offset, so you can. I'm using them on swans too, and Jeff is using them on swans. Let's see here. Intensity, 8 steps on it, so you can go real dim or real bright.
And they are bright.
Yeah. And here's the article. Again, go to Ron's webpage, and the whole thing will be published there. This looks like a duplicate slide there. Again. Oh, I'm hitting the up button. No wonder. Okay, that's it.
One question, Mark. In terms of lead time for delivery, is this an import with a long lead time?
Yeah, it takes about 3 weeks, but
3 weeks.
The seller has almost 100%, and I've ordered about 5 different times. I order them in multiples of 10, and no problem getting them.
Single conversion only.
Single conversion only, yeah.
One, so like a 4-line, could do it on a TR4, you'd have to have 2 of them.
Yeah, like the swans.
Right.
Right. Okay.
It's only 1 hour, so up and down.
Thank you, Mark. And let me just mention, too, I've been forced to buy some things from China and some other countries and so forth because I haven't been able to find a local vendor in this country. And for whatever it's worth, some of these overseas vendors will get things to you like instead of a week to 10 days. And I don't know how they do that, but I've gotten special connectors and so forth from China, and I had it like inside of a week. And I don't know how they do it, but they're really quick in some cases. Okay, next presenter is Ron, WB4HFN, that has some unique items he's going to be presenting to us. Need a laser pointer?
Oh, this is too high for an old man.
Just press the button.
Thank you, sir. Good morning, gentlemen, ladies, everyone else. You too, Mark. All right, this is the theme of this particular year is home brewing. And that's what I love to do. So I will talk a little bit about some homebrew modifications that I've done. By the way, during my discussions, the L4B and the TR7 are both over here for close inspection. We're going to start out. You remember about 3 years ago, I built an L4B. Slight modification included. How do you work this thing? There you go. I took out the one tube, and I put in a high voltage power transformer and put in a power supply over here. It was a 1-tube L4B. It was ran about 700-800 watts. And I was thinking, why can't I leave both tubes in there and still have the high voltage power supply? So it took me a couple of years to figure it out, finding the right transformer, and I came up with this. This is an L4B, an original, but it has 2 tubes. It also has the fan. I'm using the same identical under chassis cooling system blowing up through the tubes. I put the high voltage transformer here, and the power supply board is squeezed between the outside edge and the plate tuning coil. As a matter of fact, I had to use 2 different size filter capacitors. The 4 on top, you're going to see are about a ½ inch shorter than the ones on the bottom, just to clear the tank coil. So this is now a completely self-contained L4B. Both tubes with the high voltage power supply built into the main chassis. That's why I call it an all-in-one. So that's what I've been doing for the last year or so. This is where the power supply folds out. To work on it and service it, it bolts to the side in 2 bolts and it'll fold down, but that's what it is. And you can see these capacitors, which fit under here, are about a ½ inch taller than these up here, which are up against it, the tank coil. And I also put some heavy insulation in there just in case there was any arcing, and never had a problem. This is the new blower assembly that I used. These are available at ESS Electronic Surplus Place, Manchester, New Hampshire. They're $12 each. I used to live up there and picked up a couple of them and had them for years and didn't know what to do with them. But that thing fits perfectly in there where the old blower was. Actually, I had to move it over about 3 or 4 inches because of the power transformer, so I cut a new hole and I ended up putting the metal plate in the back of it. So that is, again, the 2-tube all-in-one L4B. All right, the next one, I have a TR7 project radio, and I'm trying to think of everything I could do to it. Anyway, I started out, I wanted a 110 volt power supply in it, so I put in a 110 volt power supply. And then Mark found these LED digital readouts, so I decided to put one of those in there. I got rid of the analog dials, and I put in the nice little display under the main tuning dial. By the way, the TR7 you're seeing up there and the L4B are both over there. This is what the LED display looks like. I ended up cutting the top middle strip off on each end. I have to cut the metal frame out about 1/4 inch top and bottom and 3/4 inch on each side to get the new, bigger display in place. Now, this is what the display looks like. This is the same one that Mark used in his 4-line equipment. Top is the front. This is the front, or this is the back, and that's what the board looks like. And, of course, the front. Now, and as you can see here, here's where it's mounted in. And this is what's left of the DR7 board. The DR7 board is actually 2 completely independent circuits. Completely independent even from the point that you can cut the board. This is the side that manipulates the VCO and the counters to produce the right frequency. You can also keep the up-down switches working by just this much of the board. The rest of the board that kind of goes over here is nothing more than a frequency display that picks up the VCO frequency minus this 48.05 IF frequency and displays the resulting frequency, which is the same thing as that new little display is doing. So what I'm doing, I'm sampling the VCO output frequency from here, driving that particular display module, and I minus a 48.05 IF, and it displays perfectly the actual operating frequency, and this is just as accurate as the complete DR7 board. But now all the problems in the DR7 board that I've hardly ever seen have always been over here in this counter circuit, so I've eliminated that by just cutting it, just like I've shown you here. You have, this is all you need with that display. Let's see, what else we got? All right, this is a close-up view of the DR7 board where I've cut it. And you have to cut it and follow the traces. But if you cut it like I've done, you don't have to do any trace cutting or resoldering or anything. The circuits are completely separate. Let's see. Oh, and by the way, the power supply board that's over on this side, I no longer need it because I built in the 110 volt AC supply. So I put those 6 controls, or 5 controls, because my 10 volt regulated is now fixed at 10 volts. So those are your 5 mode frequency sets. And this is the DR7 board in its entirety. And next to it is what I cut off. So you can kind of see I've only cut off this side, and the rest of this just becomes unusable. Now, the main problem, since I put the AC power supply in where the PA7 went, I don't have any room for a power amplifier. So what I did, I took the pre-driver stage out of the PA, made it a plug-in device. Now I plug the PA pre-driver where the old power supply was, and I took, this is the flat pack, the drivers to the final. I took those out, and I made that the PA, and the output of this is low impedance, so I added a reverse transformer that came out of another one on the top, and then this is where I take my output from the matching transformer, and I get roughly 20 watts out. So now the TR7 is basically a 20-watt QRP rig, but it runs on 110 volts. Now here's the power supply, and this is where the PA final is, right here. This is a fan where the fan normally goes. This is it runs off of a 36-volt power transformer under this heat sink. I get about 36 volts, and this is the 13.8 regulator. This is the 5-volt regulator, and this is the 10-volt regulator. And then I've got a fuse right in through here. So this is the entire power supply built into it. So this is what it looks like from the front. The display, I think, it turns out and looks real nice. As you can see, I've got the TR7 over here. I am also using some solid-state LED lighting in the background now to give it an even lighting across the entire dial and S meter circuit, which is another modification. Now, what have I done so far? I've got a built-in AC power supply, 15 amp, 15 watt amplifier, the blue LED display, relocated the mode frequency switches, removed the entire analog frequency display, the DR7, installed the new blue LEDs, transmit pre-driver section was now moved to where the old power supply was. I've also replaced all the mixers with low noise mixer diodes in front end. And what are some of the things? And as you'll notice that in through here, the old set frequencies has been relabeled the front panel, and now it's they're different functions. You might want to take a look at that. And then coming up, some of the things that I'm going to be doing, I'm going to get rid of the analog PTO, and I'm going to put in one of these new digital VFOs, which will mount on the side, and I'm going to have all that opening in through there to probably put another PA amplifier for full power out. The aux switch is now going to become a digital IF filter. Now, these are what things I'm still going to do in the future. It's going to be a digital IF, so I'm going to have 8 programmable bandwidths, all digital controlled. That's going to be put in it. I'm going to put that digital VFO in it, and instead of the A, B, and the C functions for the IF filters, it's going to be A and B VFO selection. When you plug them both, when you push them both in, it's going to be split frequency. And the dial that you see right in here, this area that's lit up, that will light up when a VFO is selected. If you don't have a VFO selected, it won't light. So that's how I know when I have a VFO selected. But anyway, really the IF filters, digital filters, the VFO are some of the things that I'm still yet going to do. But like I said, this is my project radio, and this is where I have fun. All right, any questions? By the way, when you come over and look, I got a bunch of pins with my name and everything on it. If you ever need to contact me, laying over there. One of them has a pull-out calendar, and the other one, but they're both very good writing instruments. Any questions?
Yeah.
Yes.
I'm a great newbie. I wound up with a TR2 and a whole 4C line, the separates with an amplifier and a heavy tuner.
Yeah.
I have not applied any power to these things yet. I'm looking for some pitfalls or advice to starting this up so A, I don't damage them, and B, some critical points to test out during the process of beginning.
Okay, there's actually 2 answers to that. One, you can use a variac and bring it up slowly. I've not done that in the past because I repair them, and I've also found that when you do that, sometimes components that are going to fail will fail later on. Whereas since I'm repairing them, I just plug them in. Because when I'm repairing a radio, if there's something that's bad or it's going to go bad, I'd rather it go bad now rather than ship it back to the customer and have it fail later on. So I just plug it in directly, and what happens, happens. And rarely, if ever, do I see a failure. Some of the safeguards, you might want to just check, put an ohm meter across the high voltage connections. Make sure you've got like a diode effect, a high and a low resistance, and then that the diodes aren't shorted, because usually when you do power up, it's usually one of the power supply diodes that shorts, and then it immediately blows a fuse. Other than that, I just plug it in and let it go. But for someone who has equipment that may or may not be able, or is a little leery and can't really fix it, or I have to have some help, I would bring it up slowly on the variac. Jeff, any comments?
Check the fuses.
Yeah.
These come in, it'll be 20 amp fuse. I wonder why. Rebuilding the power supply. Yeah. Make sure you got the right fuse. The AC4 supply, for folks that don't know, 6.25 slow flow is required, particularly because of our line voltages being 120 some volts today. It'll say 5 amps, 6.25 slow flow. Yes, Gary?
Having rebuilt the power supply.
What's that?
Rebuild the power supply.
Yeah, you might as well go ahead and redo the supply. Also, on like the R4C and that, go ahead and replace all those electrolytics and that.
Are there any common failure points, and would it be useful to check the ESR on the caps to prevent that failure?
Do what? I missed what you said.
Check the capacitors.
Check the ESR on the electronics
you
just
could
to
do that.
prevent the failure.
Might as well just replace them. They're 50 years old.
Yeah, you can almost bet that AC4 needs to be built anyway.
Yep.
There's
Right.
a kit. I know. Who has the kit?
Okay.
Keith Kit Shop in Harbach.
Out there in Harbach.
Yeah. Yeah, there's two variations of those kits. One is a single board design, and I think,
2 boards, single.
and then there's the 2-board design.
Campfest also has the.
Right,
Yeah.
right.
Replace the diodes too while you're doing
Our balls, he's out there. So Jeff,
He should be. Yeah, Jeff Harbach Electronics is usually out there every year in the flea market. Let me just modify something that Ron said. I agree with him. Sometimes just powering it on is fine. I tend to bring things up with a variac slowly, but my motivation for it is the type of variac that I have. It's got actually a voltmeter and an ammeter, and I find that as I bring it up with the variac, if the voltage starts going up, if the current starts going up at the same time, I know there's a problem, and then I shut it down. And the reason that I do that is because sometimes when you do the instant on, it will find the failure, but sometimes if an electrolytic blows, that electrolyte gets sort of messy to clean up and so forth. But, whatever procedure you use, just proceed with caution. Go ahead, Ron.
One other thing. Both the TR7 and the L4B that I talked about are over there on the table for show and tell. I also have some pins over there. Help yourself. Take a look. Take a look.
Thank you, Ron. Okay, gentlemen, we can now go ahead. We have a few minutes left here, and we have some experts like Mark, WB0IQK, Jeff, W8SAJ, Ron, WB4HFN, Gary, W8PU. So we'll open the floor to any questions. Do you have any questions about any sort of Drake equipment? Yes, sir.
I got one comment. Young man out there much for a year. It's been sitting on the shelf for some time now. You need to clean the contacts, because if they're bad, it's bad. It's bad contact. Sweep them back and forth on the mode switch, and everything in there needs to be actually contacted.
Yeah, that's a good comment. And my mentor taught me 50 years ago to periodically, and by periodically I mean like once a month, once every 2 or 3 months, activate every rotary switch, every push button, every potentiometer on a piece of equipment. Even if you're not using it, even if it's on a shelf, it'll tend to keep the oxidation off of the various components. Yes, sir.
Yeah, okay, so I have a question for Jeff again on the fuses.
Yeah.
For the AC4, you said they should be 6.25.
6.25 slow blow.
And what about for the...
That's per Drake. That's from...
Right. So 6.4 slow blow for the AC4. What about for the L4B? Making fuses.
They have,
They've got circuit breakers, so you don't have to worry about that. You're free and clear on that. Yes, sir.
What I used to, we got a lot of problem with like the band switch and the old switch with those silver contacts. What I do, I don't like squirting a lot of stuff in there. GC makes a little tool that used to come in a soldering kit, with a welder soldering. It's got a little wire brushing in. Make one that has a finer brush on it. I can't remember the number, but if you take that and cut half the bristles off and make it a little shorter, you can get right in there and
Good suggestion.
clean that out.
Good suggestion.
yeah, it's okay. The only thing is if you put too much pressure on some of them switches.
Yeah, there's a trick to it.
Yeah, particularly on the fixed contacts, they're very, very fragile.
Wipe against the external ones because you can bend them.
Right.
You always want to wipe from the center out and clean them this way in between.
Yeah, that's right.
That really does it.
Right.
You don't need much, but my R4C was crapping out on me, and I'd have to hit it on the after I did that.
Right. And you bring up a good point also. You don't want to spray wildly in there, and that's why with deoxit and so forth, I tend to use the needle dropper because it's a control, or else put it on a Q-tip or just a toothpick. You've got a control application. When you go with that spray, it goes everywhere. You have no control over it.
Typically take a paper towel and stuff it underneath the switch anyway to absorb anything.
Good idea. Good idea. Yes, sir, back there?
Got a specific question.
Sure.
Anybody have a source for the plate parasitic choke for an L75? I bought a brand spanking new, but it had the 3X 500 stolen from it. It had been awarded in California as a prize and never been used.
All I can say is that Ron WB4HFN has fabricated one, and he knows how to do that. Ron?
I'll have an article on my website as soon as I can write it on how to make it. But basically, you can go and buy 1/4-inch wide brass strips. I took 3 turns of that around a little X-Lite R101 screwdrivers. It's about 3/4 of an inch in diameter, 3 wraps out each side. I took little crimp-on connectors. I cut off the circle ends, soldered it to it, ran 3 wires through the center. As a matter of fact, look on the L4B, you'll see 2 home grooves up there. It's the same thing as in the L4B or the L7. The parasitic chokes are the same.
But I'm talking about an L75.
75 is the same. It's all the same thing. They're all 3-500s. They all.
I understand that, but and I haven't. I acquired a choke for an L4 or L7, but it won't fit. It's built differently. It won't fit in there.
Okay.
Everything is placed different. Everything is placed different. The main RFC, it's different, and the dimensions are all different.
I think Ron's technique can still be used to fabricate one.
The choke itself is the same if the length is a little different. But I won't disagree with you, but okay.
Looking forward to the article, Ron. Dino, did you have a question here?
I just wanted to let folks know, if you have an L4B power supply and you lose the transformer for some reason, rarely ever go. I had one go. Hamvention Manufacturing is building high voltage transformers for all sorts of unique and old boat anchors. They just built me a new Peter Dahl style transformer for my L4B. It cost $390 plus about $30 shipping. And I still haven't put it all together yet. It just arrived last week. But if you're looking for one, go to Hamvention Manufacturing. DigiKey is their supplier here in the United States. You have to buy it through them because they're in Canada. But there is hope if you're missing an old high voltage transformer or a boat anchor.
Yeah, thanks, Dino. And we'll look for an article or a presentation next year. Go ahead, Dave.
Another question for you on cleaning the female end of the L4B power supply. So do you actually push a pipe cleaner?
Yes, I do. And there's 2 types.
Spreading the connector?
Yeah, what I do is I use a pipe cleaner. There's 2 styles. One has real soft fibers on it and so forth, and the other one has real stiff ones. I use the stiff, and I do push it in there, and it seems to go in there because Yeah, it is, because the metal core, if you will, the little twist in the pipe cleaner is actually smaller, I believe, or the same as the thickness of the connector, and I've not had any problems with it. And I've been doing that for years. And right, so you don't want to be indiscriminate. You don't want to put anything too wide in there or double up or anything like that. Was there another question back? Yes, sir.
How do you oil an L7 fan?
The L7 fan you cannot oil. It's got sealed bearings on it, and you have to replace the fan if it gets noisy, unfortunately.
Who sells those?
A variety of places do, but you'll have to get the number off the back, and you can get them on eBay, and some of the vendors have them. It's a Rotron fan. I think it's a 450S or a 450, just a straight TA 450, I believe.
Thank you.
You bet. Yes, sir.
Tom People, DVI. I've got a TR4 CWRIT and the on-off switch. It won't make every time to replace it, that on-off switch.
Jeff, you want to field that?
I don't rebuild them. Ron is rebuilding.
I rebuild them. You gotta find something that's real similar, and you can do it.
Sure.
Leave it on and use an external.
External switch, that's a good idea.
Power strip. Has the
Right.
switch caps. You can take it apart and replace it. John Kreiner has the switch caps.
Okay, there you go.
Sells them for a couple of bucks a piece.
Okay, gentlemen, I think we're about out of time here. I want to wish everybody an enjoyable stay. Don't forget the minor prizes in how. Oh, wait.
Your retirement?
Yeah, I guess this is my retirement. I've done this for 10 years, and so we're looking for volunteers for next year and beyond. We're passing the baton. Thank you all.
Guys, I'd like to thank Evan for his service throughout the year. So, again, anybody who wants to take this over, we're looking.